Exchange and exploitation of data from asset management systems using vendor-free format.
Building information modeling, BIM, is already being used successfully in practice, for example in the planning and construction of building and infrastructure projects. The industry foundation standard, IFC for short, used in BIM and many different authoring software for digital exchange, provides the basis for this. BIM is therefore a tool for clear and unambiguous cooperation between the different parties involved in the construction process, so ensure project success. The use of BIM in the operational phase of structure and road construction projects has not yet been implemented in practice. We believe implementation of the BIM over the entire life cycle of a structure or a road will allow owners to achieve significant efficiency and cost savings, not only for the individual national road authorities, but for all stakeholders involved throughout the life cycle of the structure or road. The application areas include condition assessment, structural inspection, winter service operations, data on material behavior, as well as the planning of maintenance measures. Achieving digital transfer of information without data loss offers considerable added value for all parties involved. BIM also offers added value for the asset management of structures and road infrastructure. A range of data are already collected at different points in time, describing the change of road condition during its life cycle. Through the standardization of data associated with BIM, information that was previously only used as detailed information within the single life cycle stage can also be made available for many other decisions about construction and maintenance measures. This requires linking the BIM method with proven data flows and already existing asset management systems and creating new connections to existing software tools.
So what information needs to be linked to make this data flow work?
Within the framework of the AMSfree research project, the relevant construction material data were first identified which are significant for statements about the service life of structures and pavements. For this purpose, existing national concepts in Europe were used. Thus, for example, the individual layers of a road are geometrically localized by the BIM model and can be described with different material properties. These material properties, in the form of features or feature groups, are often referred to as property set or P set for short. The content of the P sets is often determined by investigations, e.g. by core sampling or during construction. Up to now, however, they have difficult to determine at a later date due to the lack of application of the BIM method, or only with a great deal of effort. This data should now be accessed and analyzed anytime. For this purpose, new P-sets were defined for the BIM models.
Do the new features remain in the BIM model?
No, the data can be stored in databases, for example, together with data that already exists. The AMSfree research project has therefore also dealt with linking of BIM models with information from existing information sources. This is because information from already existing asset management systems should be able to be utilized easily with the information of a BIM model, even if the data description does not correspond to that of the BIM model.
How does the linking of the database data with the model work?
A methodology has been developed to connect and share the data. The methodology is based on the open standard ISO 21597 Information Container for Linked Document Delivery, abbreviated ICDD. This enables an IT environment for capturing and linking data from different formats. With ICDD, the data is stored and linked as a package. The linking and transfer of data from different data sources and different data formats is done with the help of semantic web technology in the form of ontologies described by Resource Description Framework and Web Ontology Language. Via the developed web-based ICDD platform, the information containers can be linked to existing asset management databases. The data from the database is rewritten into the semantic web language and imported into the information containers, enabling the link to the BIM model. Conversely, data from the BIM model can also be transformed into the semantic web language. Using Sparkle queries, data from the BIM model can be filtered or summarized according to predefined information requirements. The selected data can then be returned to the original database. In the research project, these existing data are in a separate database in order to be able to show the procedure.
Does this also work with other databases?
Yes, our example shows how the principle works. External data can be transferred into the BIM model with using IFC format in the form of psets and can also be imported back into the original database. This procedure can be transferred to other databases, such as those used by the national road authorities under consideration for roads and structures, by means of an IT technical adaptation. BIM has so far been used primarily for new construction projects. Linking structural engineering data from the construction process via the BIM models with existing asset management systems results in new synergies. By linking the already existing information systems with the new data, a lot of data can be visualized for the first time. Through the joint presentation, facts that were previously difficult to understand can now be evaluated together. These insights will result in better decision making. The methodology demonstrated in the AMSfree research project therefore contributes significantly to a future-oriented solution to the asset management tasks of our road infrastructure.